Yes. How do you read? 5. Okay. So today we are going to start with the topic pressurization, which is ATA chapter number 2120. I would ask everyone to open your FCOMs, please. So, Asmit, can you tell me what is pressurization?
Pressurization is the process of maintaining
Bolo
a higher
pressurization, not pressurization.
yeah,
Pressure.
pressurization.
Pressure. Sure.
Pressurization.
Pressure.
Pressurization.
Correct. Once again.
Yes.
Yes. So, continuing, what is pressurization? Pressurization is
It's the process of maintaining a higher pressure in the fuselage and the cabin, cockpit, cargo section, and the avionics bay of the aircraft as compared to the ambient pressure by the means of the packs, mixture unit, and the outflow valve.
absolutely correct. प्रेशराइजेशन हम लोग करते क्यों हैं? See, at a higher altitude at 37,000 feet, 38,000 feet, the pressure around is really low, or 2 pounds per square inch, 2 psi, 2.5 psi, something like that. At about mean sea level, the pressure is about 14.7 psi at ISA. Okay. Now, what they have told us at about 10,000 feet ISA के ऊपर जितना आपका प्रेशर है, ठीक है, that is not good for, that is not habitable for humans. So at any given point of time, we have to keep the pressure inside the cabin at a value which is at an altitude similar to that of an altitude which is less than 8,000 feet. 10,000 तो हम लोग रखेंगे नहीं, 2,000 का तो हम लोग खुद भी मार्जिन रखेंगे, राइट? सो 8,000 फीट पे जितना प्रेशर होता है, कितना प्रेशर होता है? 10.9 psi. इससे ज्यादा प्रेशर रखना है हमें. कोई डाउट? At ISA mean sea level, correction, at ISA 8,000 feet, the pressure corresponds to 10.9 psi. कोई डाउट है? अब now what I want you guys to do is, I want you guys to imagine,
So 14.7 is at sea level.
yes, ISA mean sea level, just like 1013 hectopascal, same. Okay. Now, do you know what gives the aircraft the structural ceiling? This pressurization load of the aircraft gives the aircraft its structural ceiling. So now, so as to explain this to you, we have this aircraft. This aircraft's skin is able to withstand a certain amount of differential pressure. Now, what is differential pressure?
The difference between the ambient pressure and the cabin pressure.
तो शाबाश, यहाँ का प्रेशर और यहाँ के प्रेशर के बीच का जो डिफरेंस है, दैट इज डिफरेंशियल प्रेशर. एनी डाउट्स? नो डाउट्स, वेरी सिंपल. ठीक है. So now what is differential pressure? We have discussed. Now, the aircraft's structure is able to withstand some amount of differential pressure. Okay. एक मैक्सिमम लिमिट होगी. कितनी है वो मैक्सिमम लिमिट? कितनी है वो मैक्सिमम लिमिट? नॉर्मल ऑपरेशन में समवेयर क्लोज टू 8 psi. समवेयर क्लोज टू 8 psi. एंड स्ट्रक्चर की मैक्सिमम क्या है जो हम एवरीडे नहीं चाहते?
9
psi. So for normal operation it's 8 psi, which you can go till every day. Okay. Otherwise it is 9 psi. So what is the, as per ICAO, what pressure do we have to maintain over here? 10.9. So what is the lowest pressure that I can have over here?
11.9.
बाहर बाहर
11.9.
नहीं बाबा, आपका लोएस्ट यहाँ पे तुम 8 का प्रेशर डिफरेंस मेंटेन करके रख सकते हो, 2.9। गॉट द आइडिया? प्रेशर कुकर बन गया ना, अंदर प्रेशर ज्यादा है, अंदर प्रेशर ज्यादा है। क्लियर? एनी डाउट्स? तो यहां पर कितना प्रेशर होगा? 2 डेसिमल समथिंग समथिंग। अब ये 2.9 psi मान लो, ये कौन से ऑल्टीट्यूड पे आता है ऐसे पे? At what altitude do we get 2.9 psi? वो पता किया उन्होंने। Let's say that altitude is 39,800 feet. Let's say. So now, when the aircraft is at 39,800 feet, the aircraft is at 39,800 feet. Let's say the outside air pressure is 2.7. These are exact values. These are 2.7, and the internal pressure is 10.9 psi, which corresponds to 8,000 feet. Now tell me something. Can you increase the aircraft's altitude? अगर आप एयरक्राफ्ट के ऑल्टीट्यूड को इंक्रीज करोगे तो ये तो मैक्सिमम डिफरेंशियल प्रेशर एक्सीड हो जाएगा इन दोनों को। बिकॉज ऑफ दिस द कैबिन ऑल्टीट्यूड हैज टू इंक्रीज, सो यू आर नॉट लीगल। अब तुमने बोला मैं आउटफ्लो वाल्व पूरी बंद कर दूंगा, मैं आउटफ्लो वाल्व पूरी बंद कर दूंगा और मैं जहाज को तब भी ऊपर लेके जाऊंगा, क्या होगा?
Structural damage.
स्ट्रक्चरल डैमेज हो सकता है, बिकॉज द डिफरेंशियल प्रेशर विल बी मोर देन 8 psi. So with this we have, this is the maximum altitude that the aircraft can go to, and this altitude is my structural ceiling of the aircraft, which is restricted by what? The maximum differential pressure. Any doubt? No doubt? So we have a few points here. We have the cabin pressure, outside air pressure. कोई doubt? No. आसान है. We have the cabin altitude, we have the aircraft altitude. Cabin altitude, अंदर एक static port है, वो measure कर रहा है, क्योंकि अंदर का प्रेशर मेजर हो रहा है तो अंदर का ऑल्टीट्यूड कोरस्पॉन्डिंग भी मेजर हो ही जाएगा। बाहर का प्रेशर मेजर हो रहा है तो बाहर का कोरस्पॉन्डिंग ऑल्टीट्यूड तो हम लोग ऑल्टीमीटर से मेजर कर ही रहे हैं। नाउ द रेट ऑफ चेंज ऑफ दिस ऑल्टीट्यूड is the cabin vertical speed, and the rate of change of the aircraft's altitude is the aircraft's vertical speed. So these 6 parameters and these 6 parameters always have to work together in harmony. What are the few parameters that we as pilots should be shown? We should be shown differential pressure, cabin altitude, and cabin VS. What? So we have 7 parameters that we are playing with, 7 items. These 7 items are required for the pressurization system of your aircraft. What are we shown predominantly? Delta P, cabin altitude, cabin VS. Okay? No doubts? पक्का पक्का? पक्की बात है? How is pressurization controlled? Pressurization is controlled by controlling the outflow of air, not by controlling the inflow of air. So we have a constant input of air, that's normal, but हम लोग outflow control कर रहे हैं, हवा तो constantly अंदर आ ही रही है. If we want to make sure that the pressure inside the fuselage is high, so this is your fuselage, यहाँ पे हमारे पास एक outflow valve है, मैं इस outflow valve को close कर दूंगा. अगर ये outflow valve close हो जाएगा तो अंदर का pressure बढ़ जाएगा. एंड यहाँ पे प्रेशर गिर जाएगा, मतलब प्रेशर तो गिर ही रहा है मतलब बाहर, but the differential pressure will rise. That is how pressurization takes place. Any doubts? You may make a note of this. So Krish, your doubt was that can you please explain the working of the outflow valve and its association with the pressure, right? Now let's say there is a you have a balloon where someone is blowing air continuously into the balloon, but that balloon also has a small hole, or let's you can also take the example of a bathtub where the drain is the outflow valve. Clear? Now, what will happen if you close that drain, if you close that leaking hole? What will happen to the balloon or the bathtub? It will start filling up. The amount of air particles, the air inside will increase. Correct? What will happen to the pressure inside?
Increase.
The pressure inside will increase. What will happen to the cabin altitude inside?
Will increase only.
No. What happens to altitude when pressure increases?
May reduces, sorry.
Exactly. So
Reduce.
pressure and altitude have an inverse relation. When you close the outflow valve, pressure goes up, cabin altitude goes down. Clear? Any doubts? Similarly, when you open the drains, when you open the holes, the air starts leaking out. So in this case, the pressure will go down. If the pressure goes down, the difference in the pressure will also go down, right? Cabin altitude goes up. Any doubts? No doubts?
Yes, one thing, Bhaiya, इसमें we have seen that we need to maintain a certain altitude and as well as a vertical speed, right? During climb or descent, that you need to maintain a vertical speed as well to maintain the pressure difference. So
Yes.
how do we maintain it manually with the help of that? Uh, yeah,
Man
that
vs
now,
control. So the
yeah,
man vs control is a word speed control. So let's say if you're flying straight and so the thing is, one small click is equates up to 150 feet per minute of cabin vs. One click is closely approximately to 150 feet per minute of cabin vs. Okay, any doubts so far? No, right? See, having said that, there is a bomb procedure. What procedure? Bomb on board QRH procedure, which asks you to take manual control of the pressurization of the aircraft and maintain a word speed of 0. Okay, now how do you do that? But that checklist also asks you to descend to a safe height. Okay, somewhere down in that checklist it asks you to maintain a positive differential pressure of 1 psi. So hota kya hai, the idea is I'm going to give you a few cases. Let's say you're flying straight and level. You will take this man vs control, you will adjust it so that you get a cabin vs of 0. Okay, this switch controls your cabin vs. That's all you need to think about. If you put the vs up, that means the aircraft will show you a climb. The outflow valve will close. Correction, the outflow valve will open. Okay, you select it to up, the outflow valve will open. Cabin altitude will go up. Okay, I'm talking about straight and level flight. Huh? I'm talking about straight and level flight. Let's say a straight and level. What will happen if you put the man VS2 up? Outflow valve will open and the word speed will go up. Cabin altitude will go up. If you put the man VS control to down, what will happen to the outflow valve? It will close. bird speed gonna go down, and the cabin altitude is going to go down. Now I want you to tell me, let's say you're in a climb. Okay? Your pressurization is in the manual mode. You have not touched it. What do you think will happen to your cabin altitude if you do not touch anything? The outflow valve is in the last position. As your aircraft's altitude is increasing, what will happen to your cabin altitude? That will also increase. How many of you know this? भाई मान ले तेरा आउटफ्लो वाल्व खुला हुआ है, मान ले आधा खुला हुआ, तू क्लाइंब करना चले गया, 1500 फीट पर मिनट से क्लाइंब कर रहा है, तेरा कैबिन ऑल्टीट्यूड भी तो क्लाइंब करेगा ना, 700 फीट पर मिनट से, 500 फीट पर मिनट से, तो उसको क्लाइंब करने देगा इतना हाई रेट से? What will you do? You will close the outflow valve. So when you're climbing, what do you anticipate will happen to the cabin altitude? Shoot up at a very high rate. So you want to reduce the cabin VS. So you will take the man VS control and you'll make it go down. So even when you're climbing, you will take the man VS control and you will make it go down. Tell me, Krish, you seem to have a doubt.
No, I'm just trying to link it. Um, so if I push it to man VS down, which means I'm
Outflow valve
reducing,
will,
which so I'm correlating it with pressure. So मैं down कर रहा हूँ, so मेरे को pressure increase करना पड़ेगा, which means to increase the pressure, I will have to close the outflow valve, right?
yeah.
Okay.
What you're thinking is, मैं डाउन कर रहा हूँ तो मेरे को प्रेशर इंक्रीज नहीं करना. हाँ मतलब what you're saying is, you thinking about it like this: down corresponds to outflow valve being closed, which will increase the pressure. That's the sequence of events. ठीक है? हाँ, आप कॉन्सेप्चुअली सोच रहे हो, मैं आपको क्रोनोलॉजिकली समझा. Got the point? Similarly, when you're descending, let's say the manual control पे, outflow valve is in its last known position. तुम डिसेंड कर रहे हो, तुम्हारा आउटफ्लो वाल्व एक ट्रिम स्टेट पे है, तुम वहां से डिसेंड कर रहे हो. व्हाट डू यू एंटिसिपेट कि तुम्हारे कैबिन ऑल्टीट्यूड के साथ क्या होगा?
Decrease.
वेरी गुड. लेट्स आई एम डिसेंडिंग एट अ रेट ऑफ 2000 फीट पर मिनट. My cabin altitude will also come down at what rate? 1000. 2000 है तो 1000 होगा. Do I want that steep of a rate? What will I do? Up. So this is just a general way of understanding it. However, in real life, you will look at your cabin VS on your recam cruise page पे ही दिख जाता है. ठीक है, क्रूज पेज पे ही दिख जाता है मैन बीएस. यू विल एडजस्ट द मैन बीएस ऑन योर ओन. अगर तुमको लग रहा है मैन बीएस बहुत ज्यादा नीचे जा रहा है, अप कर दो. मैन बीएस बहुत ज्यादा ऊपर जा रहा है, डाउन कर दो. दैट इज द सिंपलर वे ऑफ डूइंग इट. व्हाट आई टॉट यू राइट नाउ वाज द conceptual explanation. Do you want to make a note of it?
और भैया वो स्पेसिफिक रेट ऑफ डिसेंट या तो क्लाइम हम फिगर आउट करेंगे उसका पोजीशन देख कि कितना जा रहा है अभी ऊपर रेट ऑफ डिसेंट. अच्छा 500 पहुंच गया, रिलीजिंग द नॉब,
नहीं
ऐसा
नहीं
कुछ
नहीं.
रहता है
So
क्या?
always remember, this is there in the FCTM. Whenever you're using the knob, you have to, it's a toggle switch na. It's not a, it's a spring loaded switch. So you do not press and hold it. You tuck and then you leave it, and then you wait. Because when you're in the manual mode, it is said that the CPCs have limited resolution of the outflow valve. This is there, it's a note on your FCOM. The outflow valve has limited resolution and it takes some time for the input to register. So if you press push and hold it and wait for 500 to come, boss, by the time you actually leave it, by the time you actually leave it, one second, जब तू 500 देख के छोड़ेगा ना, तब तक वो 700 800 पहुंच जाएगा 5 सेकंड बाद. So you tuck, leave it, 150 फीट पर मिनट पे वो जाके सेटल होगा. देखो 300 चाहिए, एक और बार टक कर दे, खत्म. कोई डाउट?
मैं अपने लिमिटेड रेजोल्यूशन बोला था, व्हाट्स दैट?
We'll go through it in the FCOM. It's a word, it's a phrase in the FCOM. We're gonna go through it. Do you want to make a note of this? Make a note of it. Welcome back, guys. Let's resume from where we had left. So now let's go to general. Okay. How do we remember details about pressurization? We remember 3, 4, and 5. We have 3 modes of operation. We have 4 functions or 4 modes in which the entire pressurization works. And in order for this to work, we have 5 components: 3 modes of operation, 4 functions, or we can say 4 phases of flight, 5 components. Okay. What are the 3 phases? Or correction, what are the 3 modes? Automatic, semi-automatic, and manual. What is the difference between the 3? Can anyone tell me? Asmit?
In automatic mode, the cabin pressurization is fully automatic and controlled by the CPC by the information fed in the FMGS.
Correct. So
And in
in this case,
semi-automatic,
it takes data from the FMGC, the outside air pressure, and the internal pressure, and it manages the pressurization profile according to the flight plan in the FMGS.
yeah.
That is completely automatic. No pilot input is needed.
Yeah.
What is different in the semi-automatic mode?
In the semi-automatic mode, if there is any problem and the CPCs can't get the data from the FMGS, we have to manually feed the landing elevation from the knob in the overhead panel.
Perfect. Very good. Very nicely said, Asmit. Semi-automatic mode is a mode in which data is not being able to be fetched from the FMGS and landing elevation has to be fetched. In this case, he will manage the pressurization profile so as to reach our landing elevation plus a certain amount of pressure during landing. Okay. Lastly, we have the manual mode. What is the manual mode?
In the manual mode, we manually control the position of the outflow valve from the toggle switch in the overhead panel.
Correct. Now, in the automatic or the semi-automatic mode, we have these 4 functions. Okay. So we have a pre-pressurization, pressurization in flight, and depressurization. This happens during takeoff. Okay. This happens during landing. This happens on the ground. This is the entire thing which happens in the flight, the details of which we will be studying over here. Clear? Done. Automatic pressurization profile is automatic, and the FMGC gives us the landing elevation. Gives it to whom? The CBCs. Semi-automatic mode, the FMGCs are failed. The landing elevation knob is a pilot input using a knob. And in the manual, this happens when the CPCs have entirely failed. That means we have lost complete automatic control over the outflow valve. Outflow valve is controlled manually. So CPC1 can control the outflow valve, CPC2 can control the outflow valve, and we can manually control the outflow valve. There are 3 ways by which we can control it. So the outflow valve is controlled by how many motors? 3 motors. Having said that, there are 5 components as well. 2 CPCs, full form is cabin pressure controller. RPCU, residual pressure control unit. What is residual pressure? Subal.
It is after pressurization or depressurization, the remaining pressure left out in the cabin is known as the residual
बोलो
pressure.
cabin.
Cabin,
Cabin.
cabin,
Cabin.
cabin.
It's not cabin kiru. It is cabin.
Oh, cabin. Yeah.
ठीक है. So absolutely residual pressure. ये क्यों होगा? Why will we have residual pressure in the cabin if the CPCs are not operating normally? In such a case, okay, there is jamming of the outflow valve and number of things. Okay, then we have the outflow valve and it has three motors. We have studied it right now. We just went through it. Apart from this, let's say if all of these they fail, you have the safety valve. What is safety valve? Safety valve is like a pressure cooker's whistle. So how does a pressure cooker operate? It's a closed cylinder. You heat it up. The food gets heated up in the pressure cooker in a pressurized chamber. But when the pressure goes beyond a certain value, what happens? There is a weight on top of the कुकर, जिसको हम लोग हिंदी में सीटी कहते हैं. निकलेगा, ऊपर उठेगा एंड वहां से स्टीम बाहर निकलेगा, सीटी बजेगी. यही होता है, करेक्ट. अगर वो सीटी नहीं होती तो क्या होता?
ओवर प्रेशराइज हो जाता, फिर ब्लास्ट होने के चांसेस थे.
करेक्ट. सिमिलरली अगर यहां पर भी हुआ तो ब्लास्ट होने के चांसेस थे. That's why we need a safety valve. It's a pneumatically operated valve. मतलब हवा के प्रेशर से ही वो खुल जाएगा. Clear? Then we have a control panel. Control panel is on the overhead panel of the aircraft. Okay. कहाँ पे है? Overhead panel पे. This is lights. This
Light.
is rain. Probe and anti-ice. उसके बाद
Right side of probe and anti-ice below the.
करेक्ट, यहाँ पे. ठीक है. कितने बटन है इसमें? कितने बटन है, स्विचेस है? 4. कौन कौन से? Man VS control, which is a toggle switch. Cabin pressurization manual control. Landing elevation knob. इसके बाद वाला बटन क्या है?
Reaching.
Correct. Is it a guarded button? Correct. Very good. So you know the control panel. Any doubts in this page? Any doubts in this page? No? पक्का? एफकॉम भी देख लो, उसमें भी कोई डाउट हो तो बताओ.
भाई सेमी ऑटोमेटिक मोड में ट्रांसफर जब ही होगा जब दोनों एफएमजीसी फेल होगा, है ना?
नहीं, नॉट नेसेसरीली. हाँ मतलब जब दोनों एफएमजीसी फेल होंगे, डेटा सिस्टम डेटा करप्शन. जरूरी नहीं एफएमजीसी फेल हो, एफएम भी फेल हो सकता है, जरूरी नहीं एफजी फेल हो.
भाई रेडियो 1.
Can you hear me? You may go to pressurization. You can go to general and read over it. Thereafter, you can also go over automatic operation and manual operation. Let me know once you have done reading it. So the next DU in the FCOM is architecture. Let's have a look at architecture. In the architecture, it shows us how is the outflow valve controlled with the help of computers, and these computers कहाँ से data लेते. Very importantly, sometimes they ask questions on, yes.
गलती से हुआ, गलती से.
So sometimes they also ask you questions on where is this data taken from. So the cabin pressurization controllers, which are two computers, how many of them are there? Two computers are there. So we have CPC1 and CPC2, and these computers have a cross link. Yes, Kunal.
भाई वो एफकॉम से डाउट है, एक लाइन
Yes,
समझ.
tell me.
वो ऑटोमेटिक ऑपरेशन में लिखा है इसने कि व्हेन एफएमजीएस डेटा इज नॉट अवेलेबल फॉर ऑटोमेटिक प्रेशराइजेशन द क्रू ओनली नीड टू सिलेक्ट द लैंडिंग फील्ड एलिवेशन. फिर वो
Absolutely.
सेमी ऑटोमेटिक मोड नहीं हो गया?
हाँ, और सेमी ऑटोमेटिक भी तो ऑटोमेटिक के अंदर में आ जाता है, बट सेमी.
तो लेकिन दोनों मोड्स अलग क्यों है फिर? एक ही मोड में कर लेते.
एक second, I'll tell you. There was a line in the previous FCOM where it stated that there are three modes of operation. Look at the general wala line. Go to the FCOM general. You read the second last line. What does the line say? The flight crew can set the system to operate automatically, semi-automatically, or manually. Now, what these guys have done is they have taken automatically and semi-automatically and explained it in the automatic section. That's what they have done is. Okay, valid doubt, but किया है उन्होंने ऐसे तो we cannot really say anything. Okay. Now let's come to the architecture. We have ADR 1, 2, and 3. We have FMGC, we have landing gear, control indicator unit, EIU, and immer ram air. Now ये सारा डेटा CPCs में जा रहा है. क्या क्या जा रहा है? ADR क्या क्या डेटा दे सकता है? बाहर का प्रेशर देगा, बाहर का ऑल्टीट्यूड देगा. बेस्ड ऑन दैट वो डिफरेंशियल प्रेशर मेंटेन करेगा एंड कैबिन ऑल्टीट्यूड उसके प्रोपोर्शन में मेंटेन करेगा. नाउ टू कंप्यूट द प्रेशराइजेशन प्रोफाइल I need the landing elevation, which the FMGC will give it to me. Now landing elevation तो ठीक है, landing elevation पे pressure कितना है? वो भी तो चाहिए. तो मैं जब FMGC के परफॉर्मेंस पेज पे डालता हूँ QNH 1008, वो उसके बेसिस पे मेरा पूरा प्रेशराइजेशन कंप्यूट करेगा. ओके. नेक्स्ट, लैंडिंग गियर कंट्रोल इंडिकेटर यूनिट. ऑन फ्लाइट on ground logic, which is based on the weight on wheels, बताता है CPCs को, because CPCs have a ground function as well, CPCs have a landing function as well, takeoff function as well. Now takeoff and landing का कैसे पता चलेगा, which brings us to the next one, EIU, engine interface unit. Okay, what is engine interface unit? Okay, we'll come to what engine interface unit is, but वो देता क्या है हमें? TLA देता है. What is TLA? What is the full form of TLA, guys? No? Anyone who knows it?
Thrust lever angle.
Very good. Thrust lever angle. So in your ECAM, when you see the thrust lever's position, the thrust lever's position is like, ये ऐसा N1 का R कैसा रहता है? यहाँ पे you must have seen this blue colored dot. This blue colored dot or this ball is the position of your thrust lever. ठीक है? The thrust lever can actually also be set all the way to climb gate, but the actual thrust is denoted by the green line over here. So this is the position of the TLA. This is the position of the actual thrust. Easy. TLA से मेरे को पता चलता है कि मेरा जहाज टेक ऑफ में है, लैंड में किस में. कोई डाउट? पक्का पक्का? Great. Now, also I had a question that I asked you. What is engine interface unit? You all know what FADEC is. What is engine interface unit? See, FADEC, let's say this is the engine. There is a computer dedicated to the operation of the engine, and that computer is called FADEC. Now, FADEC, there are a number of things which are dependent on the engine. For example, you have the bleed air system, the BMCs, right? You have the BMCs. You have the ACSCs. Cooling demand is not satisfied. You also have cabin pressure controllers. Okay. You have a ton of other computers as well. Not only this, you have the flight warning computer, fire detection units. बहुत सारे computers हैं. Not only this, we have a number of control panels. We have the fire control panel. We have the engine master control panel. We have the man start panel. We have the thrust levers. We have the FMGCs. ये सब कुछ डायरेक्ट फेडेक को देगा भाई. कॉम्प्लेक्स नहीं हो जाएगा फेडेक. एंड साथ में फेडेक को करना भी क्या है, इन सबसे इंटरेक्ट भी करना है और अपना इंजन भी चलाना है. इंजन में 1000 सेंसर्स आर देयर. इट्स अ टफ जॉब फॉर हिम. सो इन लोगों ने बोला फेडेक. फेडेक का दूसरा नाम है इलेक्ट्रॉनिक इंजन कंट्रोल, ईईसी. ये आपकी गाड़ियों में भी होता है. इसका प्राइमरी टास्क रखो जहाज और इंजन को उड़ाने का. बाकी ये जितने भी इसके इंटरफेसेस हैं, इनकी क्या रिक्वायरमेंट्स है, उनसे इंटरेक्शन के लिए मैं एक अलग कंप्यूटर बना देता हूँ. वो है EIU. ये सब इंटरेक्ट करेंगे EIU से. EIU फिर फेडेक को बताएगा. सो इट्स एन इंटरफेस यूनिट. इंजन के साथ तुमको इंटरफेस करना है, तुम डायरेक्टली फेडेक के साथ नहीं करोगे, EIU के साथ करोगे. इजी. Any external system has to interact with the FADEC. It won't directly interact with the FADEC. It will give its data and its request to EIU. EIU will prioritize it, filter it, and give a direct command signal to the FADEC. FADEC, do this. For example, ACSC में cooling demand satisfied नहीं हो रही. You want to pump up the bleed pressure output by some percent. सर ब्लीड नहीं मिल रही. EIU बोलेगा 5% बढ़ाओ उसको, N1 को. Clear? Any doubts? पक्का? Someone had a doubt? दिख रहा था मेरे को. Kunal, you had a doubt? No? Okay. Lastly, we have emergency ram air. This is also an input to the cabin pressure controllers. Why? Because whenever you press the emergency ram air button, outflow valve goes to 50%. कौन करेगा? CPC तो करेगा. Now the CPC takes all of this data, and based on all of this data, it computes a pressurization profile and it sends out sufficient outputs, required outputs to the outflow valve, so that it can maintain that pressurization profile. उसको close करना है, open करना है, क्या cabin rate रखना है, सब कुछ outflow valve करेगा. CPC directly उसको command करेगा. Where is this outflow valve located? It's on the right hand side of the fuselage, on the aft side. Okay. The CPC1 ECAM को डेटा देता है, CPC2 भी ECAM को डेटा देता है, and it controls the outflow valve to motor 1 and motor 2 respectively. If this is failed, we have this panel. We have this panel. मोड सिलेक्टर, इसमें एक पुश बटन है, अगर मैं मोड सिलेक्टर पुश बटन को दबाऊंगा, अ मैन लाइट इन वाइट कलर्स विल कम ऑन, which basically tells them कि भाई तुम्हारा जो CPC 1 था या जो CPC 2 था, अब उसमें से डेटा नहीं जाएगा, ये स्विच एक्टिवेट हो गया, अब आप इससे कंट्रोल करोगे। यू प्रेस इट अगेन आफ्टर 10 सेकेंड्स, अगर CPC 1 था तो CPC 2 पे स्विच ओवर हो जाएगा। सो देयर आर टू फंक्शंस। सिस्टम रीसेट के लिए इसको यूज किया जाता है, ग्राउंड पे भी कर सकते हैं, एयर पे भी कर सकते हैं। ओके ओके, सो CPC 1 in this manual backup mode, let's say you press the mode selector push button, then in this case ECAM पे जो सिग्नल्स आएंगे वो CPC 1 के थ्रू आएंगे। Okay, in the manual backup mode, that is all that you need to know. We have a man motor which controls the outflow valve. Okay, any doubts? No doubts? Do you want to make a note of it? You may make a note of it. There are questions on the highlighted portions. Okay, पूछा जाता है कि यार बैकअप मोड में कहाँ से डेटा जाता है, CPC 1 से जाता है ये कैम को डेटा। Make a note, read the FCOM, raise your hands once done. You may also ask me any doubts if you have. So I asked you to go through the EQRH checklist for cabin overpressure. Let's just quickly go through it. Are we all on the EQRH cabin overpressure checklist? Okay, so it's a amber checklist. If delta P is greater than 9 psi, when will delta P be greater than 9 psi? When the safety valve has failed to operate. Okay, Tarun, what you said previously was right. The safety valve should operate at 8.6. But this is a checklist when it does not happen. If the delta P is greater than 9 psi, that's the case. So I'll start from the beginning of the checklist. What it says is pack 1 or 2 off. Or, not both, one of them. दोनों ऑफ कर दोगे तो cabin pressure, excess cabin knowledge. You don't want that. Now we have ventilation blower and ventilation extract to override. What will it do? It will put the avionics system into the smoke configuration. What does the smoke configuration looks like? It will take data, it will take the air from the air conditioning duct. So now, if you put it to ventilation blower and ventilation extract to override, वो air conditioning duct से हवा लेगा, avionics को cool करेगा, and it will throw it overboard. Are we all aware of this configuration from our previous classes? है ना? क्या होगा इससे? अंदर की हवा बाहर जाएगी। पहले की मदद से आप पैक बंद कर रहे हो, यू आर टेलिंग देम भाई ऑलरेडी अंदर ओवर प्रेशर हो रखा है, स्ट्रक्चरल डैमेज हो सकता है, डू नॉट सेंड इन मोर एयर. Then you're putting the ventilation and blower to override, extract to override, which is putting the aircraft avionics system in a smoke configuration. It's taking air, throwing it outboard, basically depressurizing the aircraft. Now delta P, frequently monitor, okay, makes sense. Now if the delta P is more than 9 psi, then land ASAP red. Pack 1 and 2 off. Closing of the entire supply. 10 minutes before to the landing, ventilation blower and ventilation extract to auto. ठीक है, क्या बोला अस्मित? ओपन कॉन्फ़िगरेशन, फ्लाइट में
मतलब
ओपन
ऑटो
कॉन्फ़िगरेशन, फ्लाइट में ओपन
अच्छा
कॉन्फ़िगरेशन
नहीं
होती है.
बिफोर लैंडिंग है वो 10
So it says 10 minutes before landing. You'll just put it to auto. You want it to work in the automatic mode, nothing else. ठीक है, हम लोग नहीं चाहते कि that you land with it in the smoke configuration. Okay. Lastly, before door opening, check delta P is 0. What will happen if the delta P is not 0? What will you do if the delta P is not 0? बताओ.
We'll use RPCU.
Very good. RPCU. तब भी नहीं हुआ तो
वही आउटफ्लो वाल्व को खोल देंगे ना शायद से.
करेक्ट. आउटफ्लो वाल्व खलास खत्म नहीं है, तब क्या करेगा? अगेन ventilation blower override, extract override. That's what you're going to do, and you're going to try and, for example, residual pressure in the cabin जब होता है ना, 1 second. So the idea was that you will put the ventilation and blower and the extract to override, and you will try opening the gate, the cockpit door. ठीक है. ये तब होता है बेसिकली when the cabin crew they want to open the door, but जैसे ही तुम वो डोर को ओपन करने के लिए खोलते हो वो लाइट जलती है that the cabin is still pressurized. ठीक है. So that's the door operating procedure. Now you have learned this.
RAM air,
Sorry.
RAM air.
नहीं नहीं, RAM air का क्या होगा?
Residual pressure maybe helps.
But see, even if you open the RAM air, let's say the cabin is in an overpressure aircraft, what is the purpose? RAM air को जब आप open करोगे, क्या करेगा वो? It will open the RAM air inlet valve, immer RAM air inlet valve, but will the air flow? Air will only flow when the delta P is less than 1 psi because of a check valve. We have studied this. पढ़ा है नहीं पढ़ा है? Air conditioning में. Krish, when you press the emergency RAM air button to on, when does the air flow? What are the 3 cases? What are the 3 conditions? Krish, I'm asking you.
Check करना पड़ेगा. 1 second.
The last chapter taught to you was air conditioning. You have a test tomorrow, so you will have, all of you guys will have an oral test, a viva tomorrow on air conditioning. Better be prepared. Something has been taught in class, you don't know it, it will be on you. I'm making it very clear. I'm going to be very strict with the standards here. Clear? No doubts? Chalo. Now let's go forward with the outflow valve and the safety valves. We have one outflow valve. कहाँ पे है? This is the tail section of your aircraft. The outflow valve is on the aft and the bottom side. Somewhere over here is the flotation line of the aircraft. Let's say flotation line वो लाइन है कि जहां अगर आपका जहाज पानी में उतरा तो किस लाइन तक, किस स्टेशन लेवल तक आपका पानी आएगा, कितना हिस्सा पानी के ऊपर रहेगा, कितना हिस्सा पानी के नीचे रहेगा. Okay, what is the flotation line? That is the flotation line. Now the outflow valve is one valve with two flaps, two doors, so it operates kind of like this. ठीक है. अगर उसको खुलना होगा वो ऐसे खोलेगा, ऐसे खुलेगा, ऐसे खुलेगा. ठीक है. Any doubts? Now these two flaps on these two doors of this one valve are driven by 3 electrical motors, which we have discussed already. Okay, कहाँ पर है इसकी position? It's on the right hand side behind the aft cargo compartment. It is on the right hand side behind the aft cargo compartment. Is it above the flotation line or below the flotation line?
Below.
So ditching push button press करेंगे तो इस valve का क्या होगा?
will be sealed.
सील्ड नहीं, दोनों बंद हो जाएंगे. ठीक है. Any doubts on outflow valve? Yeah. Any doubts on outflow valve? Now let's come to safety valves. Again, there are two valves. This time these two valves are not below the flotation line. Why? क्या हम लोग चाहते हैं कि पानी इसके अंदर, इसके थ्रू अंदर घुसे? नहीं. So we have kept it very easily and बहुत बढ़िया से हम लोगों ने इसको फ्लोटेशन लाइन के ऊपर रखा. These two valves are pneumatically operated. This is electrically operated. This is pneumatically operated. Pneumatically operated का मतलब क्या होता है? If the delta P is more than a certain value, the air will flow. It's a two-way pressure relief valve. What do you mean by two-way pressure relief valve? अगर बाहर प्रेशर ज्यादा है, लेट्स से अंदर प्रेशर ज्यादा है, बाहर प्रेशर कम है, and the difference is more than 9 psi, pressure relief कर देगा. However, this thing is not built for inverse pressure gradient. What is inverse pressure gradient? सबमरीन में बाहर प्रेशर ज्यादा रहता है, अंदर कम रहता है. सबमरीन में बाहर प्रेशर ज्यादा रहता है, अंदर कम रहता है. So this is negative pressure differential. If the negative pressure differential goes beyond a certain value, 1 psi, खुल जाएगा. So वो आउटवर्ड भी रिलीफ कर सकता है, इनवर्ड भी रिलीफ कर सकता है, दोनों स्प्रिंग्स एंड बॉल्स की मदद से. ठीक है. कहां पर है ये? प्रेशर बल्कहेड पे. व्हाट इज प्रेशर बल्कहेड? दिस इज योर A320 एयरक्राफ्ट. आपको पता है एक एयरक्राफ्ट बनता कैसे? एक एयरक्राफ्ट का स्ट्रक्चर कैसे बनता है? एन एयरक्राफ्ट स्ट्रक्चर इज मेड अप ऑफ longerons, frames, stringers. Do you all know this? And then the skin is attached to it. This kind of a structure is known as a semi-monocoque structure. So how does it work is, when you make an aircraft, you have a number of frames, 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 frames. You have long spars which are longerons, and in between these you have small stringers, kind of like this. अब इसके अराउंड हम लोगों ने क्या किया? हम लोगों ने स्किन रैप कर दी. ठीक है. So these skin and the frames together take up the pressurization load. What kind of a pressurization load? The radial stress or the hoop stress. ये वाला जो स्ट्रेस होता है, ये वाला जो लोड होता है, the stringers and the skin together takes it up. However, ये जो तुम्हारा पूरा जहाज है, इसमें सामने एक फ्रेम रहता है, पीछे भी एक फ्रेम रहता है. It's a solid metal plate. This solid metal plate is responsible again for taking the pressurization load in the axial direction. तो ये जो प्लेट है, इसके ऊपर लगा रहता है सेफ्टी वाल्व. सामने वाली ये वाली बल्कहेड वाली प्लेट पता है कौन सी होती है? रडोम जिसपे चिपका रहता है. तो एक आपको बहुत मोटी सिल्वर की या टाइटेनियम की आपको प्लेट दिखती है, सिल्वर रंग की, मेटेलिक रंग की. दैट इज द फॉरवर्ड प्रेशर बल्कहेड. क्या कहते हैं इसको? बल्कहेड कहते हैं. व्हाट इज अ बल्कहेड? Which takes the pressurization load. It's the last frame, it's the most forward frame. Clear? No doubts? समझ आ गया? वाल्व्स दो हैं, इंडिकेशन एक ही है. कब खुलता है? ये दो वैल्यूज पे खुलती है. ये दो वैल्यूज इंपॉर्टेंट है. You may make a note. You can also go through it through the FCOM. Raise your hands once.